Hit the subscribe button or visit us at auau.auanet.org.
Using 3D scanning to create a CNC machine polyurethane bed for patient positioning during percutaneous nephrolithotomy. Nephrolithiasis is a cause of significant morbidity in patient populations with musculoskeletal abnormalities, spinal cord injuries, and multiple sclerosis. One such abnormality that can occur in this population is an upper limb contracted across the patient's chest, which makes prone positioning for PCNL difficult in order to prevent undue pressure on the patient's upper limb. Our objective was to present a case report on the design and implementation of a custom polyurethane bed designed from a 3D scan and produced using computer numerical control, or CNC machining, to create a custom cutout to reduce pressure on a contracted upper extremity. This was a novel application of CNC machining in healthcare, with the most closely related application being custom wheelchair cushions. We present a case of a female patient with a history of congenital hydrocephalus and multiple limb contractures, including having her left upper arm contracted across her chest. This contracture presented a unique positioning challenge in the operating room, and we aim to apply this custom foam bed to reduce pressure on her upper limb and chest while in the prone position. 3D scanning was performed using a Microsoft Kinect and a laptop computer. To protect patient privacy, a volunteer was used to demonstrate the 3D scanning process, which can be easily accomplished with the patient supine on a standard exam table or hospital bed. In the top right of the screen, the inset video shows a view from the Kinect's cameras, as well as the live generation of the 3D point cloud. The 3D model is then imported in a mesh mixer for further editing, with several stages of processing, including closing any gaps in the 3D model, removing excess material such as the patient bed that was recorded during the scan, smoothing any jagged edges or artifacts, using a Boolean difference operation to subtract the patient's body from a cube representing the foam material, and removing any overhangs from the foam cutout model that cannot be CNC machined using a drill bit operating straight down. And finally, we reduce the number of triangles and details to speed up later processing steps. Next, the model is imported into Fusion 360 for the final processing stages, including conversion into a mesh body so that a toolpath for the CNC machine can be generated. The toolpath is a map that the CNC machine follows and is shown overlaid on the final model. We then use a CNC machine to cut the desired shape into 5-inch thick foam stock. This foam thickness allowed for adequate depth to accommodate the patient's body shape, while also leaving enough to provide adequate cushioning for the patient. A specialized foam cutting bit and compressed air are both used to ensure a clean cut without tearing the foam material during the machining process. Inset in the top right is a simulated toolpath that was generated by Fusion 360 to preview and troubleshoot the final production process. The toolpath settings we selected are shown on the right of the screen and can be adjusted to work with the different foam materials or to trade a lower level of detail for a faster machining time. The final product was brought into the operating room for the patient's procedure, during which the foam bed performed remarkably well. As you can see on the left side of this slide, the fit of the foam bed was confirmed to the patient on the hospital bed before being transitioned to the operating table. Next, the foam bed was placed on the operating table and the patient was flipped directly into the prone position onto the foam bed in the picture shown on the right. Small adjustments are easy to perform in the operating room as the foam is easily cut to allow for last-minute modifications. In this case, the only modification that we made was cutting a small amount of extra space for the anesthesia headrest at the patient's neckline. Some future improvements for similar projects could include better integration with the anesthesiology head support, creating the 3D model using a CT chest, abdomen, and pelvis scan, which would remove the requirement for an additional 3D scan, in this case, the step that we use the Microsoft Kinect for. Additional changes to the bed could include a full-length bed for patients not undergoing split-leg procedures, and modifications to the model shape to allow for flex prone positioning. And future projects would also compare the pressure distribution versus standard positioning techniques. And finally, the production and machining time could be streamlined to create a faster production process. With regards to limitations, the foam density may not be high enough to support the full weight of morbidly obese patients, which could be addressed with using different types of foam. The depth of cut is limited by the CNC machine equipment, including the shaft and router bit used. In this case, it was deep enough for a 3.5-inch cut. And finally, the CNC machines large enough to support the material height needed for foam projects such as this are not widely available for public use, but many research institutions do have these machines available for private use. In conclusion, this project demonstrated a novel use for custom contoured polyurethane beds in the operating room to assist in patient positioning, and we demonstrated a reproducible workflow for the 3D scanning and CNC milling production process. Overall, the custom bed performed successfully within the operating room, providing both easy prone positioning and adequate cushioning for the patient's contracted upper limb. Finally, the authors would like to thank the Glickman Neurological and Kidney Institute and the Cleveland Clinic Hillcrest location for their support of this project, as well as special thanks to the students and staff at the Sears ThinkBox of Case Western Reserve University for their time and expertise regarding the CNC machine equipment. Thank you for your time.